So the three properties of exponents that I asked you to write down, this is from last period. One student wrote down x to the z times x to the power of t equals x to the z plus t power. We're adding our exponents. The power property x to the y raised to the z power is x to the y times z. Here we multiply our exponents. The quotient property, x raised to the power of a over x to the power of b is x to the a minus b. The properties for exponents, what we do with our powers. What we do with our powers, we add, we multiply, we subtract. Today we're going to talk about the properties of logs. What's a log? A log is an exponent. So when we look at our three properties of logs, we're going to have the same properties, product, power, quotient. Same thing we did with exponents. The first one we'll look at is the product property for log. A log is an exponent. So when you take the log base b of a product, so m times n, and you go back and think about what did you do with your exponents in the property, product property for exponents, what did we do with them? We added them. So we're going to separate the m times n and make it log base b of m plus log base b of n. The yellow arrow that you see tells you that this property works in both directions. So if you've got the log plus a log and the bases are the same, you can put them back together as the log of a product. Sometimes that will make simplifying easier. So I put a couple of examples down here, just simple ones for you to look at. Log base 3 of 5 times x, we can separate it to log base 3 of 5 plus log base 3 of x. The log of a product separates to the sum of the logs. What's the point in doing that? There's no point for this example other than to show you the property. In the second example, log base 4 of 2, you can evaluate log base 4 of 2, but it's not really that important for you to be able to evaluate that. The same with log base 4 of 32. We can evaluate those, but it's not as easy as we would like. If we reverse the product property here and we put these two logs back together, log base 4 of 64, that's an easy one. 4 to the third power is 64, so log base 4 of 64 is 3. The product property for logs becomes the sum of two individual logs. And again, it works in both directions.
And the base of the log has to be the same?
Great question. The base of the log must be the same. If the bases are not the same, they're not, you cannot combine them. Different animals. Okay. Second property that we looked at was the power property for exponents. The power property for exponents can be applied directly to the power property for logs. Log base b of a raised to the power of n. So in other words, you're doing log base b of a to the m power. Remember, log base b of a is an exponent. M is also an exponent. What do you do with your exponents? You multiply them. So the m drops right down in front of the word log. You take the power on the a, drop it right in front, m log base b of a.
In the problem where you were graphing, would that m become the vertical stretch factor?
If you were graphing, we wouldn't do that if we were graphing.
Right.
It wouldn't be anything like this. This is not going to apply to graphing at all. because if you were graphing, your variable has to be in the power position. Unless you're graphing a log function, and then that m probably isn't even going to be there. You wouldn't have the log base b of x squared. So here's two examples. Drop the 2 in front of the log base 5 of x, so you get 2 log base 5 of x. And drop the 2 in front of the log base 5 of 25 to make this easier to evaluate. What's log base 5 of 25? 2. And 2 times 2. 4. We keep piling on more information. There's people who can't graph logs in the room. And there's people who don't know the most important thing we have learned this chapter, and that's the definition of a log. And we're looking at log base 5 of 25, and there's a couple people right here, right now, who said, huh? Log base 5 of 25 is 2? What the heck? I thought it would be 5. This doesn't make any sense to me. And yet we're still not asking the questions. We're still not studying these things every night. And we're still wondering, why is this class so hard? Got to keep these things in order. Let me go back here for a second. If you could pull out your calculator, we can look at this properly. If you can do log of 200, I wouldn't expect anyone to have this memorized. But see if you're getting the 2.301 for log of 200. Everybody okay with that? Tell me another way I could rewrite the number 200. 100 times 2. Okay, 100 times 2, I think I have just one of mine. So 100 times 2. 100 times 2, how do I use the product property for that? Log of 100 plus the log of 2. And the log of 100 is 2. If you do the log of 2, you get 0.301. Product. Right? You have the log of 200 right here. I'm saying the log of 200, we could call it 100 times 2, right?
Yeah.
That's a product. So if this is a product, we use the product property to separate it. Now log of 100, everybody should know is 2. The log of 2, we know it's less than 1, more than 0. It's 0.301 on the calculator. And when you add them, 2.301. Same thing we got here. So I want you to see that the product property works. All right? And remember, what is this 2? What is this 2? An exponent. It's the exponent on the 10, base 10, that gives you the 100. What is the 0.301? An exponent. That's what a log is. It's a power. So when we look at this, 2.301 is an exponent. It's the exponent you put on a 10 if you wanted to get to 200. Another way to do 200. 50 times 4. Another way. 10 times 20. I'm not trying to, I only have the 10 times 20 already up here. 50 times 4 would work too, but you'd have to use the calculator for both of them.
Yeah.
With the 10 and the 20, when we apply the product property, we have log of 10, common log of 10, and common log of 20. The common log of 10 we should know. What is it? 1. Common log of 20, between 1 and 2, closer to 1. Use your calculator. It should be 1.301. When you add them, again, 2.01. These are exponents, the 1 and the 1.301. Product property becomes the sum of the powers. It's easy to mess it up if you don't keep it roughly straight. The most common one is to multiply them. Log of 10 times log of 20. Not one word. So we have the product property, we have the power property. What's the third property? Quotient property. This is the one you want to put a little star by, the quotient property. It's the one that is most commonly done erroneously because it looks like our last property today. When we get to the last property, you'll say, hey, that's quotient property. And you mix the two up. It's very easy to mix them up. When you have the log of a quotient, so it's important to define that we're doing the log. So the word log appears one time. Of a quotient. So log of a fraction becomes the log of the top, the numerator, minus the log of the bottom, the denominator. All that technical talk there. That allergy season kicking in. So when you have something like log base 3 of x over 7, we can separate it to log base 3 of x minus log base 3 of 7. And if you have log base 2 of 1 minus log base 2 of 8, you can put them back together to have log base 2 of 1/8, which is negative 3. This is nothing we can really do. Again, this example is for nothing more than showing here's how the property applies. It doesn't really do anything for us. It's just the applying of the quotient property. As we progress through, when we come back from break, you'll see that you want to be able to pull them apart in order to solve for the unknown, say x. So they'll be in an equation, and then things will start to make more sense as to why we're doing it. But that's Eric? No? Now again, there's still a half a dozen people in here. I don't need to take notes. Those same people are the same ones who are making the careless mistakes, tests and quizzes, and they just don't have this stuff dialed. I don't know what to do for you. Okay? Yeah, but I look at your notes online. It's not the same. It's really not. Yes. So when you see the power property, here's an example where if you have this, you could definitely go back to this. Now, in this problem, it doesn't really help us, but you're going to see when we solve equations, when you have 2 log base 5 of x, you're going to change that to log base 5 of x squared. You're going to ultimately get back to the quadratics, and ultimately beyond that, factoring. Okay? So like I told you at the beginning, factoring never goes away. I did update the factoring review page. If you feel like you're a little sketchy with the factoring, go and take a look at that, back in chapter 1's first file. And if you're having trouble with the parent graphs, that parent graph file is on there too, and it goes all the way through the logs. Gives you all the critical movements, all done out for you from every single day of notes when we've done graphing. So we put them all together in one place. Makes your life a little bit easier. Log base 2 of 8x. Notice what the directions say. It says expand. We're just basically telling you apply your properties. So we have 3 of them up here. Okay? This is an easy one. And C is actually easy. So we're going to do A and C together. So we'll bring C up here. Which property can I apply for log base 2 of 8x? Product property. Log base 2 of 8 plus log base 2 of x. Should we leave it like that? Why not? It would be. Very good. Log base 2 of 8 we know. So we want to write 3 plus log base 2 of x. If you can evaluate without a calculator, you should do it.
Was that your answer? You made it 3. Oh, no.
What was that?
Yeah.
The C question, you got to be careful. Some of you are going to say, oh, we got to do the power property first. You can't. The power property, doing it first, could only be if the 5x was in parentheses. It's not. So you have to do the product property first, common log of 5 plus the common log of x cubed. And the reason why you have to do that is because the cubed is only on the x, not on the 5. Common log of 5, we leave that alone. What do you do with the common log of x cubed? It's called the power property, and it becomes 3 common log of x.
If you wanted to, would you be able to put parentheses around the common log of x? So it would be 3 parentheses over log x closed?
I guess. Why would you want to do that?
I don't know.
Okay, then don't do it. If you don't have a reason for it, you really don't want to be doing it. Log of 5? What is it? Oh my gosh, that wasn't what I was hoping for. And we didn't want you to pick up the calculator. I forgot that this one we could do on a calculator.
Common log 10.
I just want to know what log of 5 is. Did you memorize them?
No.
Oh.
Right?
Huh?
Is that right?
I'm looking for a very common phrase.
Oh, yeah.
That's the one. That would be a perfect phrase. I don't know. So that means leave it the way it is. As opposed to here, where it was log base 2 of 8, I don't know is not the right answer. 3 is the right answer. But log of 5, unless you memorize them, you should know that. I just leave it like this. See if you can do B. And I'm telling you right now, there are lots of places to make mistakes on this. So you've got to be very, very meticulous. So take a minute and see how you do with this. So the fatal flaw in this problem occurs when we do the quotient property. So log base 7 of 3x squared minus log base 7 of 5y cubed. And that's the perfect way to write it. But from here on is where we make or tend to make our mistake. How do you handle this side of the minus? Log base 7 of 3x squared. What do? Okay, so log base 7 of 3 plus log base 7 of x squared. And that's how we handle the product property for that. What do you do with the 2 on your x squared? Use the power property. So where does it go? In front. Drop that 2 in front of this log. And again, the log base 7 of 3 just stays the way it is. We're good. And I suspect that if you could do this side of the problem, then the log base 7 of 5y cubed should also work out okay. All right? So we do repeat the process, and we have log base 7 of 5 plus log base 7 of y cubed. Same concept applied twice. This is the line where the mistake was made, for me. Not for me, but what I'm showing, what happened last period, and what happened with some of you. This is incorrect. How come? How come? Why is this incorrect? We need parentheses. Because it's minus this, we need to treat it like this. Right? But we don't want to end with parentheses. So how do we get rid of the parentheses? Distribute the negative. So minus log base 7 of 5 minus 3 log base 7 of y. And I think a lot of you got all the way down, but I think a lot of you had a plus right here. Plus 3 log base 7 of y. It's a very, very, very common error. And it's one you just need to pay attention to. When you have minus, everybody has to become minus in there. Is there anything I can combine? And what would you get? Just -2? It's creative. Well, you could, but we wouldn't want to. The log base 7 of 3 over 5. We're going on the other way of the property, right? And we don't really want to do that. So you could do the reverse of the quotient property and say this is a negative log base 7 of 5, but you don't want to do that. If this was a log base 7 of 3 and this was log base 7 of 3, they would disappear. If this was 5 log base 7 of 3 and this is 1 log base 7 of 3, they would combine and give you 4 log base 7 of 3. But they're not the same thing you're taking the log of. Can't do anything with it. That's a tough problem. Is everybody clear on it? Are any of my steps? There's nothing else I can do that I can see, but I'm open to suggestions. Do you think we could go further?
No, well, you said that whenever we were solving it, like, we should be left with a log.
Right, like log base of one item here, log base 7 of x is log of one thing, log base 7 of 5, you're only taking the log. In other words, you don't want to have a product or a power or a quotient in the what you're taking log of position. Does that make sense? Otherwise, if we wanted to write it as a single log, this is how it would look. Right?
So even though you can't combine those two, the log base 7 of 3 and log base 7 of 5.
Well, we can combine them all.
But you just don't want us to.
Well, if you combine them all, that's what it would look like. The directions for this stuff here are to expand, get rid of
Okay.
products, quotients, and powers.
Okay.
So in order to expand to do that, this is what it looks like. So when you're finished, you would have the log of one I can't use monomial, but one thing only, not a product, not a quotient, not a power. Okay. See if you can do the reverse on these. So there's 2 of them here. We expanded on the last one. Now put them together and write the word log once in your answer. All right, so on the first one here, which property do we apply first?
But shouldn't you change all the natural logs to use the... Would you use the power?
You need to use the power property first. So the power property is on the second term, and it becomes the natural log of 25. Now you have a couple of options. When it's just plussing and minusing, I go left to right. That's my personal choice. So I'm going to do the natural log of 200 minus the natural log of 10 is the natural log of 20. product property. What do you do with what you're taking the log? When you're adding two logs, that's called the product property for logs. So you multiply the 8 and the 25, you get 200. And when you're subtracting logs, that's the quotient property. So the 200 divided by 10, 20. Now there are other people who would say, and they're going to go from here and they're going to say, the natural log of 8 times 25 over 10. And that's perfectly acceptable as well. That'll also take you to the natural log of 20. I'm fine with you doing that. I am not fine with the original question going directly to the answer. I'm not fine with the original question going directly to the answer. This line has to be here. And then this line or this line has to be there. I am not going to take you, oh, I'm doing it in my head. It's not going to work. You have to show the process. On the second example, what do we do first? Power property again. So the log of 2 plus the log of, not 9, 27 minus the log of 9. Remember, it's not 3 times 3, 3 to the power of 3. So the log of 54 minus the log of 9 is the common log of 6.
How did you get log 54?
2 times 27 is 54. That's the product. Remember the product property if we go back? If you have log plus log, it becomes the log of the product when we go backwards. So we're going backwards here. And then when you're subtracting logs, you find the quotient. 54 divided by 9 is 6.
Okay.
What I would encourage you doing, have them on flashcards. Put them on the table in front of you. Put them all on one piece of paper. My honors kids right now, they have all these identities. So put them on one page, have them right there. And if you need to have them in manipulated form because you can't manipulate them, I tell them, take them and do the manipulations, add them to your sheet. But if you have them there and you work with that sheet for a little while, pretty soon you don't need the sheet anymore. So if you would take them a couple minutes and do that, you'll find that your success rate will go pretty high. So the fourth property for today is called the change of base property. What's your favorite base? 10. How come?
We don't have to write it.
It's common and you don't have to write it. That's not why it's my favorite. It's on my calculator. What's your second favorite base? E, because it's on the calculator. But I'm never going to choose base E. If I have the choice, and you could say, okay, we're picking teams, and the only two players left are base 10 and base E. Come here, 10. I'd much rather work with you. Base E, you're so complicated. Base 10, nice and simple. This formula, this transformation for log base C of A is for log base, I sure as heck don't want to work with C of A, to log base whatever you want. So log base C, C is a base we don't want to work with. Log base C of A is going to become log base B of A over log base B of that original base we didn't want to work with, C. Base B is whatever the heck you want. What do you think you should be using for base B?
10.
And if you really want to go out and be crazy one night, use base E. So in the book, what they do is they take the property like this and they say, look, here's log base C of A, here's log base B of A over log base B of C. And they say, what you should be doing, if you want to do common logs, log base C of A is common log of A over common log of C. And log base b of a over log base b of c could be natural log of a over natural log of c. It's just a matter of which way you want to go, common or natural. I always pick common. It's a habit, but it's not going to change anything. Remember I told you to put a little star next to the quotient property? That's because people screw this up and think this is the quotient property because we have a quotient here. This is not the quotient property. This is the change of base property. And you notice that it's the log over the log. It is not the log of the quotient a over c. You have to do the log of a divided by the log of c. It's not the log of a over c. So when you look at the log of 64 over 20, or log base 6 of 24, and we want to do change of base. Change of base is going to be log of 24 over the log of 6. And again, if you want to get crazy, do the natural log of 24 over the natural log of 6. And right now, you should try them both. But the objective for you is to see what the answer is. What is the log base 6 of 24 going to be between? What two numbers? What two numbers will the log base 6 of 24 be between?
4 and
Why?
because 10 times 2 is 3.
That's a good guess. It is 1 and 2, but not because 10 times 2 is 20.
It's because 6 to the first is 6 and 6 to the second is 36.
And 24 is between 6 and 36. The base is 6, so 6 to the 1, that would be our power, right? 6 to the 1 is 6. 6 to the second power, 36. And we're doing the log of 24. So what power do we raise 6 to get 24? Got to be between 1 and 2. What's it going to be? 1.77, 1.774, according to Page. You've got to be able to do this on your calculator. Bring that up. So on your calculator, here it's done with common logs. Make sure you close the parenthesis on the 24. If you don't, you're going to get the wrong answer. So common log of 24 over common log of 6. You can also do natural log. Natural log of 24, close parenthesis, divided by natural log of 6. And you get the same exact value. It doesn't matter which base you use. Now, a couple of people have the special calculators, the magic calculator with the log base whatever you want button. Okay, if you have those, you can't use them, you still have to do change of base. Now, you can use them, but if you don't show the change of base, you won't get credit. Nobody writes base 10. Base 10 is common law. It's understood. Just like base E is natural law, it's understood to be base E. So we just did those two bases because they're the ones we use all the time. We just found an abbreviation for them without writing the base. So when you write log of 24, it means log base 10 of 24. We're just being lazy. Or we meaning everybody who uses it.
From either of the steps, the natural log and the other log, can you just use a calculator? You don't need to write them like that?
Don't unless you memorize them.
I don't have it in my phone.
No. Did anyone memorize one of the bases for us? Base 1, you can't have base 1. So we had people, all these people volunteered, didn't we? I know Malin volunteered. Did you learn your base? Not yet. Okay. How about see if you can do log base 5 of 11? Log base. All right, so log base 5 of 11, we should be doing common log of 11 over the common log of 5. Common log of 11 over common log of 5, what do we get?
I put 1.491 because 9 would round the 8 to a 9, maybe a 0 at the end, and the 0 wouldn't be written since it's a decimal, so I put 1. If you round it,
I need 3 decimal places. So are you telling me 4, 9,
They rounded off.
so like this?
why would you leave 0 at the end?
Because you have to round to 3 places. If you're rounding to 3 places and you put a 9, 1.49 with no 0, you're telling me it was exact.
That's not what I wrote there.
Okay, what did you write?
I rounded further so that I would have
I want you to,
a
we're
number
going to
of,
3 places.
yeah, I
On
rounded
your
further.
3rd place, what number on your calculator appears in the 3rd decimal place?
Well, on my calculator, it's a 9.
Great, look to the right of that. What do you see?
All I'm saying is that I didn't want to leave a 0 at the end of a decimal, so I just rounded further.
Okay,
Is
Again, let me
is that wrong?
yes, because you're not listening. If you write 1.49, is that what you want to write?
No.
Okay, tell me what to write.
I don't understand what you're trying to do.
My question for you, because you're not getting this as your answer, is that accurate?
I mean, I can write that as my answer.
You're not I'm not doing a good job communicating right now. You got a different answer. Yes or no?
Yeah.
Would you be willing to share with me what your answer is?
I got 1.491.
Okay, that's what I'm asking. 1.491. What does it say on your calculator?
Can you read the whole number to me?
That'd be fantastic.
1.4898961102.
That's all we need. This is the place I want to round to. We look 1 to the right. More than 5? Yes or no?
Yeah.
So
I know how to round the number. I just
Okay.
didn't think that you would want a 0 at the end of a decimal.
Absolutely, if that's what you round to.
Okay.
If you put a 1 here, you're telling me that it went 491 and then something less than a 5 is the next number. Or it was 490 and then something more than a 5.
Okay.
So like if we had 1.4906, that would become 1.491. But 1.4898, this is more than 1. You add it to here, or more than 5, you add 1 to 9, that becomes a 10, right?
Yeah.
So we put a 0 here and add 1 to this, that's how we got 90. It's like taking 89 and rounding it to the next number, 90. If that makes sense, I'm not
Yeah,
sure.
I understand how to round.
Okay? But if you're putting a 1 here, I don't think you do understand how to round. That's why I'm want to just...
Okay.
Sometimes it seems like an argument. No, I just want you to make sure you understand what we're doing. You can't drop off the 0. If you drop off the 0 and say, hey, it's 0, we don't really need to exclude it, bless you. If you drop the 0, you're telling me if we're rounding to 3 places and you drop the 0, you're saying 1.49 is an exact value answer. None of these will be exact value answers. Everybody has to have 1.490. Nothing else will be equivalent. Okay? So we don't want this. All right, so yesterday I think we talked about different applications. One of them was the Richter scale, is that right? Did I mention it in here? Yeah. So when you talk about an earthquake that's a 4.0 versus a 5.0, I grew up in Massachusetts. Earthquakes never happened, ever. The only earthquake I saw was the movie called Earthquake. When Sense Around. and you go to the theater and the theater shook. That was as close as I ever got to an earthquake until I came to California. And in my first year of teaching, we had an earthquake where my classroom moved up and down, as well as left and right. And I had lights that hung, like in the cafeteria, and they were swinging full swing. Dust was coming off of them. And the walls moved. And I had no idea what to do. I just sat there. I wasn't even afraid. I was so stupid. I wasn't even afraid. I didn't know that you needed to be afraid. I'm in California. It's an earthquake. So I had no idea. Richter scale, 5.0, 4.0. The Richter scale is logarithmic. So these are exponents, which means an earthquake of 10 to the 5th versus an earthquake of 10 to the 4th. How much bigger is a 5.0 than a 4.0? 10 times bigger. So my ignorance, East Coast ignorance, I had no clue.
Isn't like the Richter scale, they go by 30?
What do you mean by 30?
I don't know, but I know 30's in there somewhere.
Okay. Well, my limited understanding of what an earthquake is measured with is that it's a power of 10. And a 5.0 versus a 4.0, we're looking at 10 times bigger, not 1 bigger. I thought 5.0, 4.0, how much bigger could a 5.0 bigger be? Why are we even using those numbers? Those are silly. They don't make any sense until someone says, oh, they're powers, they're not just numbers. Decibels are done on a logarithmic scale. And, excuse me, pH is also logarithmic. So in your science classes, you think about a pH of 7 is neutral, right? More is basic, and less is acidic. Well, when you go from a 7 to an 8, it's 10 times less acidic. And when you go from a 7 to a 6, it's 10 times more acidic. These are going to be powers. What I want you to know about these is that when we're looking at the applications, we're going to give you the formula, and you don't have to worry about memorizing them. There's a couple in the homework tonight, but they're very basic. So when you look at this homework, they're very basic tonight, and they're not the focus of this lesson. The focus of this lesson are the early problems, and they have to do with the properties.